YouTube, what the heck is up? So it's Greg here back at you. We're going to continue on with the part 2, I think, in part B, I guess, of part 2 of grade 7 of the Show Your Work of the Hardest Math Problems. My voice is semi-healed. Again, I spoke for a few hours again today, and it's still not 100%, but it's like 10,000 times better than it was in the first part of this series. So I might still go high-pitched and squeaky and a whole bunch of other things, but we're going to give this a shot. What I'm going to do, too, is because I have limited time, is the remaining 4 questions, I think there were 4, I'm going to do one at a time and maybe combine them. I forget what the topics are, but if they're the same topic, I'm going to combine 2 or 3 together. If they're not, I'm going to do them all separately anyway. So either there's going to be 4 other parts, or 3 other parts, or 2 other parts, or I'm going to combine them all together, okay? By the way, I noticed my screen, some students pointed this out, my screen blanks out sometimes and comes back. I don't know why it's doing that. It used to not do that. I'm going to have to maybe update some of my software and see what's happening there. Luckily, it only does it for a flicker. It's not a flicker problem, though. It's somehow related to whatever's happening. And I'm going to have to Google it and try to figure that out further, because it's not really precluding anything, but I agree it's annoying. And a few you pointed out of that. And when I played it back, I noticed that it does do it. Sometimes it does it quite often. I thought originally it was related to me making a mock-up or something, but it doesn't seem to do that. Okay, I'm bantering, and my throat is stripped out. I'm not sick, by the way. I'm not going to get into why I have a sore throat, but let's jump into these problems. So we have strictly a word question here. Let me see if my tablet's going. Let me see if we're recording okay. Yes, we seem to be. All right, well, cool. All right, so this is probably going to go 15 minutes or so unless I combine it with the other ones. So we have a home improvement store that sold wind chimes for $30 each. So a wind chime is $30. Okay? You don't always have to do this, but it's worth putting down what the givens are on your sheet and visualizing anything you possibly can by drawing it. This is our default mode. So many of you get questions wrong, not because you don't understand how to do them, but because you solve them in your heads. Don't do that. Okay? That said, we do want to be proficient and have fluidity and stuff like that, but not at this level. We want to be able to be fluid in the multiplication table, in formulas, and in other aspects like that, but not every single last detail. So just try to learn your own strengths and weaknesses, and if your weakness is doing it in your head, which is true for almost everybody, you should write it down. Okay, and then learn ways to improve that skill, including finding out which parts of writing down you don't necessarily need to do. So again, coming full circle on spending time on this, because almost everybody who's going to be watching this gets this wrong because they didn't write down their stuff onto their show your work area. And I'm not talking about question 53 here, even though that's the one we're working on. I'm talking about as a general strategy to solving problems, write them down, okay? I'm being defiant here, which I normally don't get excited about, but this is just over and over and over and over and over again. I see this with students, okay? So wind chime is $30. A customer signed up for a free membership card and gets a 5% discount off the price. So it means they're going to get 30%, and then they're going to get a 5% discount. Okay, so they receive a 5%, and then the sales tax was applied after the discount. So basically, we're subtracting the 5%, and then we're adding a 5% sales tax. Okay, so the initial thing is, oh, this is easy. I have 30, I take off 5%, I add 5% back, and therefore I get 30. Why are they even asking this to me? And it's not 30, okay? That was not the final price. Okay? It's not the final price because when you take the 5% off in this part right here, you have some number, let's call it X. When you add the 5% back, you're adding 5% of X, no longer of the 30. Okay? And we'll see that with the numbers, that we're not going to end up getting back the 30. Okay? And one of the reasons I spun this off is because this is a gotcha on this problem all the time, where we have some price, we remove some certain percentage of it, and then through some other means we so-called add that percent back. A lot of students think we did nothing, okay? But it's not true. All right. The second reason I spun this off is because of this 5% here and this 5% here, we're going to get into slightly slippery multiplication, and I want to make sure that I'm doing that on the screen correctly. Okay. So the first thing we need to do is take the $30, and we're going to get 5% of that. Okay. So we're going to multiply it by 5%. 5% is the same. Percent means over 100. So we're going to take 5 over 100. Okay? Yeah? Okay? So we're basically going to get, we can cancel out here, but this is obvious enough. We're going to get 150 over 100. Okay? And that's equal to 1.5. Okay? If you can't figure that out, we could have got rid of these zeros. 5 goes into here 2 times. 5 goes into here 3 times. We have 3 halves. That's 1.5. 1.5 what? Dollars. Okay? So with our general flow here, we're going to subtract that off of the 30. So we're going to get 30 minus 150. Okay? So from that, what are we going to get from that? 28.50. Okay? So this is our price after the discount. Okay, we still need to do this step here. This was step number 1. Okay, and now step number 2 is to add the 5% sales tax back in. Okay, so we're here at number 1. Okay, and now we're going to do step number 2, which is to take the 28.50. Okay. And get 5% of that. Okay, it's going to work the same way. We can get 28.50 times 5 over 100. Because again, 5% means that whatever we're going to get, we're going to add back into the 28.50. And it's not going to be 30. All right? There's a couple ways to do this. 28.50 times 5 is nasty, but it might be one way to do it, and then divide by 100. So we can get 28.50 times 5. So 5 times 5 is 25, carry the 2. 8 times 5 is 40, plus 2 is 42, carry the 4. 5 times 2 is 10, plus 14, right? Okay? And then we have, we're going to move over the decimal place. Let me see here, 1 second. 28.50 times 5. Okay, so we're going to be here, okay, and that means we have 142.50 over 100, okay, and if we shift that over, we're going to get 142, okay. Let me just see that I did that right. Actually, there's the 5, so we get 1.425. I have slight dyslexia, so I'm just going to spend 1 second making sure that I did everything properly right now. Let's see, I have a 30% wind chime. I do 5%, so I'm going to get 150 over 100. That's 1.5. Okay, cool. I'm going to take 30 minus the 150, so 28.50 plus 150 is 29.30. That's 30. So 28.50 times the 5%. I get 5 times 5 is 5, 2, 842, 4, 10, 14, 142.5, move over 1425. Good, okay. So now what I have to do is take the 28.50 and add to that the 1.425. Now, since this is dollars and cents, should we round that up or not? Okay, it's not going to really affect it because at the end we can do it. So this is basically a 0 here. So that's 529.92. So they're asking us what is the final price. We have to round it at this point. So we get $29.93. So we can see this is pretty computation intensive. It's probably in all of the series questions I've done here, hundreds of questions, this is one of the most computation intensive one so far. Okay, I'm going to change the color of the pen slightly because there's variances to the question. So we solved the question. So far it is involving, let me just do this so because I'm going to use the space over here. That way we can keep the problem still on the screen. This is pretty much just the percent problem, adding a percent and subtracting a percent. And again, we can see we started with the $30. We're removing the 5% to get to $28.50. All right. So to add 5% back on, we're done with the 30. The 30's gone. We're adding 5% back to $28.50. So you can see that doesn't make sense to subtract 5% and add 5%. Does not bring the original number back. Because when you subtracted 5%, you scaled that what's going on down, if you will. So when you scale it up, you're scaling it out from below where you originally started from. In other words, 28.50 is less than 30. So if you bump up 28.50 by 5%, you can't get 30. It just doesn't work that way mathematically, all right? So there's other ways to have solved this. I'm not convinced they're as smooth or not. So what we're going to do is take step number 1, okay, and we're going to redo one over here. So step number 1, we broke in 2 parts. First, we got the $1.50, okay, and then we subtracted it off. We can do that in one shot. We can do that in one shot by taking 30 and multiplying it by 95%. Where did I get 95%? Because there's a 5% discount. That means the new price is 95% of the 30, okay? Right? So we could have done that computation. I'm going to do that if I do 95% times 30, right? Right? I'm going to get 0 for there. 5 times 3 is 15, 1, 27, 28, okay? It's 90, so that's 30 times the 95, and then I'm going to divide by 100. And look at that. I get back to 28.50. Okay, so that's another way to do step number 1. Step number 2, we did the 5%, and then we added it back on over here, okay? So there was 2 parts to step number 1 and 2 parts to step number 2. So now what we need to do is take the 28.50, and instead of doing 2 things, we could have multiplied it by 1.05%. Just like the 95% I got here, where am I getting the 1.05 from? Because it's a 5% on top of the full price. In this case, our full price is now the $28.50. So it's 100% the $28.50 plus 5% more. So we now have, if you did it this way, a more ugly multiplication we have to do. So we have to do that now. Okay, that's 28.50 times 1.05. Okay, if we multiply that out, we should be getting the 29.925. Okay, I'll leave that as an exercise for you guys to do. All right, I'm going to change the color one more time because there's still a way to combine all this. So as you can see, this blue way is not necessarily superior to the red way because the computations get a little uglier. Okay, so actually the space is not going to work there. So let me do this. Let me try to stick it down here. So in the brown way, we could have done it straight up. We have $30. We're going to multiply that by 95%. And then we took that number, the 28.50, and we multiplied that by 5% more, okay? And that could be equal to what we need to do. So another way to do this was the 30 times 95 over 100 times 105 over 100. Okay, and that's equal to whatever we're going to get there. We know this is ending up to give us a 29.925 thing. All right. You could probably cancel certain things here, like this 0 can cancel with that 0. Okay. Now, that's what we're trying to do is look at this. We have 30 times 95 times 105 as the numerator. If we were to just do that, we have 30 times 95 times 105 over 100 times 100. Now, often these problems are arranged so that we can cancel these numbers out. Okay, I'm not convinced we can do that so much here. And you could have made the bottom, we have 100 times 100, so that's 10. We could have made it 10,000 if we want. I'm just going to leave it as is. So this 0 here, let's say cancels that 0 there, okay? We can see that 5 goes into the denominator, certainly goes into 10 and 100, and it also goes into 95 and 105, okay? And we can almost cancel the both of those out. What the problem is going to end up here, we're still going to end up with the ugly numbers, but they might be easier. So 5 goes into here twice, the 10, okay? And 5 goes into here 21 times, all right? 5 goes into this 120 times, okay? And 5 goes into this 95, 1 with 4, 19 times, all right? So the answer is we end up with 3 times 19 times 21 over 40, okay? There's nothing else we can simplify here. So the question is what I'm going to box off right now an easier computation to do than what I'm going to circle right now, okay? It's hard to say. Is it easier to do 3 times 19 times 21 over 40 or 30 times 95 times 105 over 100 times 100? Probably the box is easier, but not by much. We can optimize this slightly. We can multiply 3 times 19 or 3 times 21. This one seems easier to me. So we basically get 63 times 19, okay? And whatever we get for that, we're going to divide that by 40, okay? And that still gives us a 29.95. So I'm going to leave you guys to do that for yourselves. Give me 1 second here. And that's pretty much the deal for this question. The blue and the brown are basically additional thoughts on how to solve this. All right. It's clean cut though. No matter how you slice this, this was a computational intensive way. I would suggest trying to solve it one of the way, the brown, the blue, or the red. What's nice is we try to present alternate ways to solve questions. And one of the reasons to do that is not just conceptual, because I'm trying to make this concept-based and topic-based, but it provides an alternate mechanism and strategy to double-check your answer by doing it a totally different way. Okay? What also happens, too, is when you do that, you can start detecting errors that may have popped up. In other words, one technique, one strategy of doing this, whether you did a brown, blue, or red, and this is universally true, again, it has nothing necessarily to do with problem 53, is that once you try to solve it a different way, even if it's just computational intensive like this, we're just changing the way we do the 5% here, right? It's not like we're using algebra for one way to do this and geometry another way to solve it. These are all just arithmetic solutions, but still, it turns out that when you try an alternate strategy, sometimes you might be like, oh, I read the question wrong. Okay, there's no guarantee that that kind of thing is going to pop up, but that's often a consideration that happens. You also have to balance this, though, because this was computationally intensive. You have to balance, like, how much time should I spend on this question? Let's say it was on a standardized exam. You have to make a balance between that. What you could do, though, is put a comment on the side and come back to it later. My strategy usually is suggest that you should solve problems live when you're at the problem by using alternate strategies, because you often will have other questions that are also time constrained that you still need to get to. All right? All right, so I'm going to end this here because I think, what are we at here? We're at 20 minutes already, so that's enough time to spend on one question, and I'll spin the others out, either 2, 3, 4. So a few things. I'm Greg from Greg's Tutoring NYC. My email is at the bottom, GregsTutoringNYC@gmail.com. I have a ton of more of these problems at GregsTutoringNYC.com/hardest-math, including multiple choice ones. Booyah! Right? They're grade level, so this is grade level 7. I have multiple choice ones for grade level 8. I will eventually get to the show you work ones for grade level 8. As well, many of you are still not grade level proficient because your schools and whatever may have happened, you jumbled up topics from here and there. So go back to grade 6 ones and so on. Many of you are prepping for a certain exam. These are wonderful questions to use for that. Again, I didn't say it for this part, but these are questions being sourced from the New York State exams where students got most of these questions wrong. So they're perfect questions to use for this kind of thing like that. Okay? All right. With that in mind, please like the video. Please subscribe to my channel. And peace. And I'll do the other parts in a second.